Your smartphone looks simple, just glass, metal, and a glowing screen. But inside a factory, it's a high-speed symphony of precision, robotics, and microscopic engineering. Let's step behind the scenes and see how mobile phones are made, from raw materials to the final box device. Raw materials and core components. Every phone begins with raw materials sourced from around the world. Silicon, copper, aluminum, lithium, cobalt, and rare earth elements form the foundation of modern smartphones. Silicon, refined from sand, becomes the base material for microchips. Lithium and cobalt are essential for rechargeable batteries, while copper is used for wiring and electrical connections. Aluminum or stainless steel is used to shape the phone's frame, providing both strength and a premium feel. These materials must be refined to extremely high levels of purity. Even the smallest contamination can have a significant impact on performance, particularly in semiconductor manufacturing. Once refined, production splits into several parallel processes, each focused on creating a specific component. The most advanced part is chip manufacturing. Silicon is melted and grown into large crystals, which are then sliced into thin wafers. These wafers are polished until perfectly smooth and placed into ultra-clean environments called clean rooms. Here, a process known as photolithography is used to create microscopic circuits. Ultraviolet light passes through masks to imprint patterns onto the wafer. Layer after layer, materials are added, etched, and refined, forming billions of transistors on a single chip. This chip becomes the processor, the brain that powers the phone. Memory chips are produced using similar techniques, allowing phones to store data and run applications smoothly. Meanwhile, camera modules are assembled separately. Tiny lenses, sensors, and stabilizers are combined with extreme precision. Even a slight misalignment can result in blurry images, so advanced robotic systems handle this delicate work. Printed circuit boards, or PCBs, are another critical component. These boards connect all the electronic parts inside the phone. They are made by layering materials and etching conductive pathways that allow electricity to flow between components. Despite their small size, PCBs are incredibly complex and must be designed with precision. Display manufacturing is equally sophisticated. For OLED screens, organic compounds are layered onto glass panels. When electricity passes through them, they emit light, creating bright and colorful images. Each pixel can operate independently, allowing for deep blacks and high contrast. Touch sensors are integrated directly into the display, enabling accurate detection of taps and gestures. Battery production is another vital process. Lithium-ion batteries are created by stacking layers of electrodes and separators, then sealing them into compact units. These batteries are tested rigorously to ensure safety and performance, as they must operate reliably under various conditions. Assembly line and integration. Once all components are ready, they enter the most dynamic part of the factory, the assembly line. This is where thousands of individual parts finally come together to form a complete smartphone. The environment here feels almost futuristic. Conveyor belts glide smoothly, robotic arms move with perfect timing, and skilled technicians monitor every stage. It's a carefully choreographed system where speed and precision must exist in perfect balance. The process begins with PCB assembly, commonly known as surface mount technology, SMT. First, a thin layer of solder paste is applied to specific nicket on the circuit board using a stencil. Then, high-speed pick-and-place machines get to work. These machines can position tens of thousands of microscopic components, resistors, capacitors, and chips onto the board every hour with near-perfect accuracy. What's fascinating is that these components are often smaller than a grain of rice, yet they must be placed exactly right. Once populated, the board travels through a reflow oven. Inside, it passes through carefully controlled temperature zones. The heat melts the solder paste, which then solidifies as it cools, locking each component firmly into place. This stage is incredibly sensitive. Too much heat can damage components, while too little can result in weak connections. Advanced sensors constantly monitor temperature to ensure flawless results. After reflow, the boards undergo automated optical inspection, AOI. Cameras scan each board, comparing it to a digital blueprint to detect missing or misaligned components. Any defect is flagged immediately, allowing technicians to fix issues before the process continues. This step ensures reliability before the phone even begins to take physical shape. Next comes the mechanical assembly, where the phone's body is formed. The outer frame, typically made from aluminum or reinforced composite materials, is machined using CNC technology. These machines carve out the frame with micron-level precision, creating perfectly aligned openings for buttons, ports, speakers, and cameras. After machining, the frame is polished, anodized, or coated to achieve its final look and durability. This is what gives smartphones their sleek, premium finish. With the frame ready, the motherboard, now fully assembled and tested, is carefully placed inside. Robotic arms often handle this step to avoid human error, gently positioning the board into alignment points within the chassis. Screws or micro fasteners secure it in place, ensuring stability even under physical stress. The battery is then installed. Because it's one of the most sensitive components, special care is taken. Adhesive strips or brackets hold it firmly, while protective circuits ensure safe operation. Next, camera modules are inserted into their designated slots. These modules must align perfectly with the external openings, as even slight misalignment can affect photo quality. Speakers, vibration motors, and antennas are added next. Each component is connected using flexible ribbon cables, which are thin, bendable connectors that allow a compact internal design. These cables are carefully routed and locked into tiny connectors, ensuring seamless communication between all parts. One of the most delicate steps is attaching the display. Before installation, the screen is cleaned in a dust-free environment. Then, a precise layer of adhesive is applied around the edges. The display is lowered into place with exact alignment, often using vacuum tools to avoid fingerprints or pressure marks. Once attached, it is pressed and sealed to ensure durability and a seamless finish. Throughout this entire process, dust control is critical. Assembly areas are often maintained as clean rooms, where air is constantly filtered to remove particles. Workers may wear protective clothing to prevent contamination. Even a microscopic speck of dust trapped under the display can ruin the final product, so cleanliness is taken extremely seriously. After the physical assembly is complete, the phone moves to the software stage. Here, it is connected to programming stations where the operating system is installed. Firmware is loaded to control hardware components, ensuring everything functions correctly. Each device is assigned a unique serial number and identity, which helps track it throughout its life cycle. Calibration is also performed at this stage. Sensors such as accelerometers, gyroscopes, and fingerprint scanners are fine-tuned for accuracy. Cameras may undergo alignment calibration to ensure sharp images. Even the display is adjusted for color accuracy and brightness consistency. At this point, the smartphone is no longer just a collection of parts. It has become a fully functional device. But as it leaves the assembly line, you can already see the transformation from raw components to a sleek, intelligent piece of technology ready to connect with the world. Testing, finishing, and packaging. Before any phone reaches the market, it must pass a series of rigorous tests. Automated systems check the display for defects, ensuring there are no dead pixels or brightness issues. Touch sensitivity is tested to confirm accurate response to user input. Camera systems are evaluated for focus, color accuracy, and image quality. Audio components, including speakers and microphones, are tested to ensure clear sound. Buttons are pressed repeatedly to verify durability, and sensors are checked for proper operation. Battery testing is especially important. Devices are charged and discharged multiple times to confirm efficiency and safety. Connectivity tests ensure the phone can connect to cellular networks, Wi-Fi, and Bluetooth without problems. Durability tests simulate real-world conditions. Some phones are dropped from specific heights, exposed to temperature changes, or tested for water resistance. These tests help ensure the device can withstand everyday use. After passing all tests, the phone enters the finishing stage. Protective films are applied to the screen and body to prevent scratches during transport. The device is cleaned thoroughly to remove any dust or fingerprints, ensuring it looks perfect when unboxed. Packaging is the final step. Phones are placed into boxes along with accessories such as charging cables, adapters, and user manuals. The packaging process is often automated, ensuring consistency and efficiency. Each box is labeled with product details, serial numbers, and barcodes for tracking. Finally, the packaged phones are shipped to distribution centers and retailers around the world. Logistics systems coordinate transportation to ensure timely delivery, often within tight schedules. Modern smartphone manufacturing relies heavily on automation, precision engineering, and global coordination. Components may be produced in different countries, but come together seamlessly in one factory. Sustainability is also becoming increasingly important, with manufacturers working to reduce waste, recycle materials, and improve energy efficiency. The entire journey from raw materials to finished smartphone is a remarkable example of modern technology and industrial efficiency. Each step, from chip fabrication to final packaging, requires accuracy and coordination. So the next time you pick up your phone, remember the incredible process behind it. What seems like a simple device is actually the result of one of the most advanced manufacturing systems ever created, combining science, engineering, and design into a product that connects the world. If you enjoyed this inside look, don't forget to like, subscribe, and comment on what process you want to explore next.